So proceeding on to the next question, that is your question number 16. A pipe is open at both ends. What is the correct about the standing wave formed in the air of the pipe? Okay, so this is the diagram. Okay, this is the open pipe which is open at both the ends. Okay, over here you can see the waves that are formed in the fundamental, the second harmonic, the third harmonic. Okay, in the pipe open at the both ends. Okay, so in the fundamental you can see that there is only one node and there are two antinodes, right? So that means in the fundamental the number of nodes plus antinodes is 3. Okay, in the second harmonic I can see that the number of nodes is 1, 2, right? And the number of antinodes is 1, 2 and 3, right? So that means the total number of nodes and antinodes is how much? 5. Okay, now in the third harmonic I can see that the number of nodes is 1, 2, 3 and the number of antinodes is 1, 2, 3, 4. So that means the total number of nodes and antinodes is 7. Okay, so in this way the total number of nodes plus antinodes will always be an odd number. Okay, so that the correct option to your question number 16 will be option number A. I hope you got the question. So proceeding on to the next question, that is your question number 17. A negatively charged particle is placed in a uniform gravitational field, is positioned midway between the two charged conducting plates. Okay, so over here this is the positive charged conducting plate and this is the negative charged conducting plate. Okay, so this is basically a capacitor. The potential difference between the two plates is adjusted until the particle is held at rest to the plates. Okay, see over here what is happening is that this is the negatively charged particle. Okay, suppose the negatively charged particle has a mass m. Okay, so that means over here the weight will be mg. Okay, mg acting downwards. Okay, and we know that the electric field between a capacitor is how much? The electric field between a capacitor is sigma by epsilon naught. What is sigma? The surface charge density of the plates. Okay, so that means over here electric field will be in this direction, E vector, right? So what will be the force acting on the particle? Since it is a negatively charged particle, the force acting on the particle will be upward, right? So that means this will be equal to your Q times of E, right? And for equilibrium what should happen? Mg should be equal to your Q times of E, right? So what will be the mg? So mg will be equal to what is q? Q is q. Okay, E is sigma by epsilon naught. Okay, so this is the equation for equilibrium. So this is the equation for equilibrium. Okay, now what they are saying? What change will cause the particle to accelerate downwards relative to the plate? Okay, so decreasing the charge of the particle. Okay, so if I just decrease the charge of the particle, what will happen? The overall QE, that is the force acting upward, will be decreased, right? So if it decreases, what happens? This will not be able to balance out the mg, right? So that means it will accelerate downward. So the correct option to your question number 17 is option number A. Okay, so if I just explore the other options also, decreasing the separation between the plates. Okay, so is the force that is acting upwards, the force that is acting upwards is Q sigma by epsilon naught. Okay, so does it depend upon the separation between the plates? No, it does not depend. Okay, it depends upon the charge of the particle, the surface charge density of the plates and the epsilon naught. So it does not depend, so it is wrong. Increasing the length of the plate, so it does not also depends upon the length of the plates also. In nowhere in the relation is the length of the plates. Okay, so if I increase the length of the plates, nothing will happen. Okay, so that means this option is also incorrect. Increasing the potential difference between the plates. So okay, so if I just increase the potential difference between the plates, what will happen? Okay, will the force that is acting upward change? No, it will not change, right? So that means what will happen? This will be also the incorrect. So the correct option to your question number 17 will be option number A, decreasing the charge on the particle. So I hope you got the question.